All right, let's use the localized electron model to fully describe the bonding in sulfur hexafluoride, or SF6. So the first thing we need to do is draw the Lewis structure for this compound. And you will quickly find that the handy hints will get you nowhere because the octet rule cannot possibly be obeyed to build the SF6 molecule. This is a case of valency expansion where sulfur takes a dodectet. That's the only way we can bond those 6 fluorines to it. And sulfur is just fine expanding its valence like that because it's a third row atom. So this is the structure of SF6 that we can build with sulfur having 12 electrons around it. So what we need to do is look at sulfur and determine its substituent number. It has 6 bonds, so its substituent number is 6. And if we look at the handout, we can see that a substituent number of 6 corresponds to D2sp3 hybridization. Once again, those superscripts, 2 plus 1 plus 3, add up to 6. So we need to have 6 D2sp3 hybrid orbitals. 6 hybrid orbitals are going to be around that sulfur. Now, all 6 fluorines are in identical environments, and the substituent number around each fluorine is 4, so the fluorines are going to be sp3 hybridized, and all 6 of the fluorines are going to be the same. If we want to think quickly about the geometry, the substituent number of 6 around the central atom tells us that this is going to be an octahedral geometry with 90-degree bond angles. So sulfur is D2sp3 hybridized, and that means that the sulfur is going to have 6 D2sp3 hybrids, and I'm just going to draw them as lobes. 1, 2, 3, 4, 5, 6. So each of these lobes that I've drawn represents a D2sp3 hybrid orbital around the sulfur. The fluorine is sp3 hybridized, and of course there are going to be 4 sp3 hybrid orbitals around each fluorine. So I could draw all of them. My drawing is going to get quite complicated if I do that. I'm going to draw my 6 fluorines. I'm going to draw one over here, and then each of the fluorines is going to have those 4 sp3 hybrids around it. And the sp3 hybrid on the fluorine is going to overlap with one of the D2sp3 hybrids on the sulfur. And that's what gives rise to the sigma Fs bond in each case. Okay, so this is really getting to look like a very floral drawing here. So every lobe that I've drawn in green is an sp3 hybrid on the fluorine. I'll just label a few of them, but they're all the same. Each fluorine, again, has 4 sp3 hybrids. Now, each fluorine, if we look at the Lewis structure, has 3 lone pairs. So you can imagine that those lone pairs are residing in the sp3 orbitals that are not overlapping with sulfur's D2sp3 orbitals. So I am putting the lone pairs in their respective sp3 orbitals on the fluorine atoms. The other electron on fluorine is going to be shared with the electrons on sulfur to make the covalent sulfur-fluorine bonds. So you can kind of imagine how that looks. So here is my pretty little localized electron model diagram for sulfur hexafluoride. Now let's put what this picture tells us into words. So we can say that sulfur is D2sp3 hybridized, and each of the 6, because there are 6 D2sp3 hybrid orbitals, each of the 6 D2sp3 hybrid orbitals on the sulfur overlaps with a fluorine sp3 hybrid to form a sulfur fluorine sigma bond. So that's how we get those 6 SF bonds. The 3 lone pairs on fluorine, I can say on each fluorine, each reside in their own sp3 orbital. So a fluorine sp3 hybrid orbital. And I think that's a pretty complete description in words of the bonding situation in SF6.